Now let us take some more examples of the same thing. So let us consider that if we can have a line, y is equal to ax plus b. In place of writing, c plus dt, we have written here equal to b. We have written here y is equal to ax plus b. E is guaranteed to pass through three given points. We can't say that a line is guaranteed to pass through given these 3 points. However, we can assume that we can try to find a line which comes closest to these 3 points, and that is written by means of the average, the squared what you call value. So whatever squared value if we consider, the error corresponding to that is least square is what we can find out. So this has to be solved in the same way, where the points x1, y1, x2, yk are there. The line we are looking for is the least square solution to the system of linear equations whose individual equations can be represented like this. So in place of writing c plus dt equal to b, we are writing here xi a plus b is equal to yi, just a little different. In place of c we have b here, in place of d we have a here, in place of t we have xi here, in place of b we have yi here. That's the only difference there. So now here a, b are the variables. At that time we had c, d as the variables. Now a, b are the variables here. So for our 3 points, we can consider 1, 2, 2, 4, 3, 8. So when x is equal to 1, y is equal to 2. When x is equal to 2, y equal to 4. When x is equal to 3, y equal to 8. So we can just try to substitute that. When x is equal to 1, we'll get 1 into a plus b is equal to 2. Then the second equation is 2 into a plus b is equal to 4. Then third equation is 3a plus b is equal to this 8. So this can be written as the what you call from this you can clearly write a is equal to 1 2 3 1 1 1 as a, and b is 2 4 8. So the what do we have in the columns of a? The columns of a just correspond to all x values 1 2 3 as the first column, and the second column is all ones because we have the b which is a constant. Okay? B which is a constant. So this is because the equation we are trying to fit is a x into a plus 1 into b is equal to y. So then we just need to compute the same thing, ATA, AB is equal to ATB. And we can just compute from this the value of AB. By computing this ATA, AT is transpose of this multiplied by this itself. That will give us a value, a invertible matrix, and then this taking transpose and multiplied with b will give us this quantity, and then we can just take AB as the inverse of whatever we have on this side multiplied by this quantity. Okay, inverse of this, what if you take it on this side, this becomes inverse multiplied by this, that will give us the value of AB. So thus we will get the solution like this. AB will be ATA inverse ATB, and ATA inverse can be found from just ATA and whole inverse, and then AT, what you call A transpose of this multiplied by B over here, multiply those two, you'll get this value. So the line which does this is y is equal to 3x minus 4 by 3. 3 is the value of x, and 3 is the value of a, and b is minus 4 by 3. Hence, we'll get 3x minus 4 by 3. So having got this value over here, you can again try to get the value of small p. Small p will be this multiplied by this multiplied by this. And then you can find the error. Error will just correspond to this minus of the small p. Small p is this multiplied by this, and this b minus the value of p will give us the value of the value of the what you call error e. Okay, so that's how we can find the error. Similarly, you can have any other problem. The graph of y equal to 3x minus 4 by 3 along with data points can be considered. We are just trying to find the best fitting line which corresponds to linear regression. So we can have points like this: 8, 10, 9, 7, 7, 9, 7, 5, 4, 4, 1, 3. That means for x value is this, y value is this, x value is this, y value is this, and so on. Then we can try to fit it onto a line which is y equal to ax plus b, or we can put it onto a parabola. Parabola means when x is equal to 8, you can substitute over here. 10 is equal to a 8 square plus b 8 plus c. That will be one equation. Similarly, second equation would be 9 is equal to a 7 square plus b into 7 plus c. And again, third equation will be 5 is equal to a 7 square plus b 7 plus c. Similarly, the fourth equation would be over here. 4 is equal to a 4 square, that is 16, plus b4 plus c. So you can keep on writing like this, or a parabola without constant term can be written, or parabola with a linear term dropped, that means we don't have the x, or might be a wheel type curve such as y is equal to a by x plus b cos pi x plus cx. So you can just keep substituting the value of x over here, and the value of y can be written. So we'll get equations in the form of a, b, and that can be solved. Even we can try to solve this also, but circle also, but this has to be rearranged. So an example is considered over here for ax equal to b. So where we'll get those points 8, 1, 7, 1, 7, 1, 4, 1, 1, 1, corresponding to the values which are written over here. So 8, 7, 7, 4, 1 is what we have here. 8, 7, 7, 4, 1. All these are 1, 1, 1 because b is just a single value. And then 10, 9, 5, 4, 3 will become the value of b. 10, 9, 5, 4, 3 will become the value. So again, it's just the same. Small a, b can be found from this. In our original problem, we might have taken this as CD, but here it will be AB. So AT A inverse ATB will be equal to this quantity. So this can be again considered as an example, an exercise, and I have just given a hint for this. So thus you can find this and you'll get this. And again, once you got this transpose, this will give us P, and this minus the P value will give us the error. Similarly, we can try to do it for a parabola. Y is equal to ax squared plus bx plus c, and corresponding to that, a squared quantity, we'll get the square of each one of those quantities. Bx, we know very well that the second column will just correspond to that x value itself. So x value is 8, 7, 7, 4, 1. So therefore, we have in the second column 8, 7, 7, 4, 1. First column will be square of this. So 8 squared, 64, 7 squared, 49, 7 squared, 49, 4 squared, 16, 1 squared, 1. And all these will be just the same. B will be again y itself, that is 10, 9, 5, 4, 3. 10, 9, 5, 4, 3 is there here. 10, 9, 5, 4, 3. And we have again a set of equations over here. Number of unknowns, might be 3, A, B, C now. Number of unknowns, but number of, observations are 5 over here, 5 rows. M is 5, N is 3. And corresponding to that, again, we can find this, A, B, C over here as AT, A whole inverse, ATB. And this can be found as this multiplied by this inverse of, take the transpose of this, then multiplied by this itself, then you'll get some equation, some matrix, and that inverse can be considered here. Then A transpose B can be found, and you just multiply that, you'll get this value. So we'll get the best fit for the parabola like this, best fit. Again, having found this, we can find the value of P, which is equal to A transpose this and the value of E, which corresponds to B minus A transpose of this quantity. Similarly, we can find for parabola with no constant, parabola with non-linear term, and a weird curve like this, and might be a equation which corresponds to a what you call um, circle, but that has to be rearranged. Rearranging this, we will get like this, and that turns out to be this, and we are writing this value, as L R square minus H square minus K square. So this is the value which we need to find. So our unknowns are H, K, and L now. Our unknowns are H, K, and L now. So corresponding to this value of X and this value of Y, we'll have X square plus Y square. You can try to write the equations for here and all that. Okay, B will be equal to the quantity which is X squared plus Y squared, and you have X here, so that will be 2X, 2Y. So whatever Y is there, you substitute that. Whatever X is there, you substitute that. Whatever X plus square plus Y squared, you substitute that. Then you'll get a set of equations, all that, and try to write it in that form, and you can try to find HKL, and then that will give us the equation of the circle. So again, this can be considered an exercise, and we can similarly do a curve fitting for the exponential curve, which is equal to y is equal to c into a to the power of x. So by taking the natural logarithm on both the sides, we'll get this equation, and then you can substitute the value of x over here, over here, and you need to find L and M. Okay, for this x, you need to find out the value of logarithm of y, and then once having found L and M, you can find the equation for the rest of the thing will be just the anti-logarithm of that. Okay, so having found C, L, you can find C as anti-logarithm of L. Then similarly, having found M, you can find it as anti-logarithm of A as anti-logarithm of M. C is anti-logarithm of L, A is anti-logarithm of M, and that is A is equal to e to the power of M. That is the value which we have got here, and C is equal to e to the power of L, and the L value is taken from here. So again, this is just the solving in the same way. Again, it can be considered as an exercise to solve the same problem. Similarly, we have the power function like this, and again, it can be solved. It's rearranged over here like this, and we put it in the form of an equation and then try to solve it.